Okay, this is the second video, part 2 of Spearman's rank correlation coefficient. If you have not seen part 1, I strongly suggest you to take a look, which will give you the foundation to understand that. If you already understand the concept, you can just follow this video as we will do some examples. So applying the concept by solving further examples and/or examination style questions. Let's get the first question here. The Malvern Aquatic Center hosted a 3-meter springboard diving event. The judges Stan and Minson awarded 8 competitors a score out of 10. The raw data is collected in the following table. So we will see here the competitors, right, from A to H, the different grades that both judges gave to each of the competitors. Okay, the first thing we're going to write down the value of the Pearson's product moment correlation coefficient, or just the Pearson's correlation, okay? So how do we do this? We just do as normal using the GDC and plugging in all those values into the calculator. So we're going to do this. Just go here into statistics, and in statistics you go to list 1 and list 2, and you just put in list 1 you should put stand score. So we're going to put here list 1, and list 2 should be the second. List 2 should be the second row. Okay, so list 1 is 4.1, 3, 4.3, 6, etc. So just checking here, 4.1, 3, 4.3, 6, and etc. Okay, and on list 2, you just put the same data that is on the table here. Okay, as soon as we have put this, how do we find out the correlation? So let me just put here back. Okay, so we go to calculation, F2, then you put regression, F3, linear regression, okay, then we choose AX plus B. What's happening here is not going, I don't know why. Okay, now we managed to do. So take a look, the R is 0.90918, so rounded to 3 significant figures is 0.909. So we have just done this, and we know that the answer is 0.909. Question B. Using the value of R, which in this case was 0.909, interpret the relationship between Stan's score and Minson's score. Okay, what can we do? We know there is a very strong correlation, right? So there are different ways of saying this. You can just acknowledge that there is a very strong correlation between the two scores. So you can say that both scores are very aligned, or they strongly agree, or just interpreting in the way that you prefer. So a very strong positive correlation. Write down the equation of the regression line y on x. So we go back here. So we have the A coefficient, which is 1.14, correct to 3 significant figures. B is 0.578. So it's going to be y equals 1.14x plus 0.578, 0.578. Here it is, 1.4x plus 0.578. Question D. Use your regression equation from part B, this one, to estimate Minson's score when Stan awards a perfect 10. Remember that the 10 is the maximum, is the end of the scale. So let's see what happens here. So y equals 1.14 times 10 plus, if we want to remember here, 0.578. So 0.578. So what happens when we multiply here by 10? We're going to have 11.4 plus 0.578. So we're going to end up having a value that is greater than 10. Okay? So when we round these two values, we get it 12. So we just use the regression equation. We plugged in the value of 10, and here's the value of 10, and we got a value of 12. Okay, let's go to the next question. State whether this estimate is reliable. Justify your answer. So, what reason can we think about that this estimation could not be reliable? Okay, if we remember that the maximum grade that can be given is 10, if we go back to the table, we will see that the value awarded to 8 competitors is a score out of 10, out of 10. So that means we cannot have, it's impossible that a judge will give more than 10. So what happens? Is it reliable? No, it's not reliable. Why? Because the value is beyond the maximum. So it cannot be greater than 10. So here we get 1 for answering correct and get 1 mark, there are 2 marks here, for given our justification. Another possible justification could be the value is outside the range. So the range in terms of minimum and maximum value. So the official answer will be the estimate is not reliable as the data is outside the known data range, or a score greater than 10 is not possible. The commissioner for the event would like to find the Spearman's rank correlation coefficient. So now we want the Spearman's rank, which is RS. So remembering that this one has to follow a rank. So we're going to get the same data. So we're going to put here the other table. That's the original table that we used to find the Pearson's correlation coefficient. We're going to now use the first, second, third until the eighth and find out the numbers according to what we did before. So I'm going to change the color here. So let's take a look on the first row, Stan score. So the highest value is 7.5. So the highest value is 7.5. So we put number 1. It's the first one on the rank, number 1. Okay, what happens? The second value is 7.2, is letter E. So this should be the second one, number 2. Okay, after this one, we have 6. So after the first and the second, we're going to find out that Stan's score of 6 actually is present in 3 different competitors. So 6, 6, and 6. And we know that will be the third, the fourth, and the fifth position, or position 3 plus position 4 plus position 5. And then we have to divide by 3 this way because that's the mean. So this is going to be 12 divided by 3, which is 4. So in this case, we're going to have for D 4, for F 4, and for H 4, which is already there. Okay, now let's carry on. We have found out so far 1, 2, 3, 4, 5. So we're going to go to the sixth position, or number 6, which should be the 4.3. 6, the 4.1, 7, and the 3 is position 8. Similarly, we're going to do with Missun's rank. So the top one is 9.5, number 1. The second one is 9. So it's going to be 2 here. The third one is 7.8, so 3 here. Now notice that both the fourth and the fifth, or vice versa, they are 7.2. So what we're going to do, we're going to do 4 plus 5 divided by 2. So we're going to get 4.5 for both the competitor D and H. So 4.5, and H is already here, 4.5, done. Okay, the next ones will be 4.8, which will be the sixth, 4.7, which is the seventh position, and 4.6, oops, which is the eighth here. So now we have the table completed. By copying these values, we have the table here, and we're going to use it to find the Spearman's rank. So I'm going to go to the calculator. We go back, so we have to erase all the value here. If you have done this already, put in your calculator, you can just move forward in the video. I'm going to put the values here. So the first one, list 1, is going to be stands, just like we did for Pearson's. So this is going to be list 1. This is going to be list 2. So it's going to be 786, 786, 42414, 42414. Then we go to 786, 786, 4.5, 321, 4.5. So 3, 2, 1, and 4.5. Let's just remember that we are already on the regression, but I'm going to go back so you can see. So what do you have to do? We put regression F3, linear regression F1, then AX plus B, and we're going to find out the R is 0.9326, which is 0.933, correct to 3 significant figures. So 0.933 correct to 3 significant figures. Just a reminder that the Spearman's rank is related to the rank, but the way we calculate is exactly the same. We put on the calculator and we find the regression, the linear regression, and we find the correlation coefficient R. But in this case, it's actually RS. Okay? So it's not the way that we calculate that changes, but the way that we create the table. Okay, let's make a comment on the results obtained for RS. Stan and Minson strongly agree on the ranking of competitors. Okay, that's it. It could be also Stan and Minson strongly agree, or they are strongly aligned with the ranking of competitors. It doesn't matter the way that you contextualize this. Okay, so let's go to question 1I. The commissioner believes Minson's score for competitor G is too high and so decreases the score from 9.5 to 9.1. Explain why the value of the Spearman's rank correlation coefficient, RS, does not change. So let's take a look at the table again. What happens if we change this to 9.1? Which one's going to be the number one on Minson's score? It will still be the G competitor, competitor G, because 9.1 is greater than 9. So in terms of the rank, nothing changes. This will be the number one. So that means because the rank doesn't change, RS also does not change. Okay, that's a second examination question. You can pause the video and do it by yourself, and then you can carry on to see if you need to see how to solve it. Carla wants to measure the extent to which two judges in a gymnastic competition are in agreement. Each judge has ranked the 7 competitors, as shown in the table, where 1 is the highest ranking and 7 is the lowest. Okay, so we have here already. Calculate Spearman's rank correlation coefficient for this data. So the first thing, what we have to do here, for the Spearman rank, that's okay that the judge did like the competitor A is on the rank position 1, B is position 2, C and D are position 3. That's okay, the judge one did this. But for the Spearman's rank, we cannot have equal values if they don't represent the mean, the average mean. In this case, because we have like, this will be the third and the fourth position. In this case, what would we do? We would have to get the position 3 and 4 and find the average mean, which will be 3.5. So we have to replace this 2 by 3.5. So that will be the third, 3, and the fourth. The fifth is correct, but the sixth and the seventh, we have to do the same thing. So we'd have to do 6 plus 7th position divided by 2, which will be 6.5. So these two we have to replace by 6.5. And for judge 2, we would have to replace the 5th and the 6th position. So position 5 and 6 divided by 2, which will be 5.5. So by making these substitutions, then we would have something like that. 3.3, 3.3, 6.5, 6.5, and 5.5, 5.5. Okay, so let's find out the coefficient. So it says it's 0.817. Okay, let's check. So we're going to go back to our calculator. And first thing, we erase all the data. And we're going to put judge 1 on list 1, which is 1, 2, 3.5, 3.5, 5. So 1, 2, 3.5, 3.5, 5, and 6.5, 6.5. And judge 2 will be 2, 3, 1, 4. So 2, 3, 1, 4. And 5.5, 5.5, and 7. 5.5, 5.5, and 7. Remembering that if you're starting to put the data on the lists, you will see that we have to first choose regression line or linear regression. We will choose x because it's the linear regression, and the type of the function is ax plus b. So ax plus b. We're going to have here the r is 0.8165, which is to three significant figures 0.817, as we found, as we had found before here. Okay, so that's it. It's correct. State what conclusion Kyla can make from the answer in part A. So this is also a strong correlation. So what we're going to say in terms of the judges 1 and 2. There's a strong agreement between the two judges. That's another way of saying it. There's strong agreement between the two judges. Or judges 1 and 2 strongly agree with the results. That's it for today. I hope you have enjoyed. May the force be with you always.